would request Mr. Deep to please start up with his session, as well as also introduce himself briefly. So, Deep, over to you. Deep,
Hello. Yeah. Am I audible now?
yes, Deep, you're audible. Now I can hear you.
Okay. So thanks, Sunny. It's always a pleasure to hear you after a long time.
Thank you.
As charming and sweet smiling that you look like. Okay. So good evening once again, my dear friends and colleagues of the fraternity. So nice to have you here in this lockdown mode. Of course, I met few of you last time also during my last session, and wonderful introduction by Sunny over there. So I'll not take much time. I will start my presentation on the topic of dual phase migratory corrosion inhibitors. So, to just give a small introduction, my name is Deep Bundi, and I'm working as a product manager with BASF and Master Builder Solutions in the repairs and protection coating segment. Roughly about 26 years of experience in the field, and let's hope I can sort of tickle some bone in that technical aspect today. All right. So is my screen also visible? Can somebody please respond to me because I have gone on a full screen mode.
Yes, Deep, your screen is. We can see your first opening slide.
Okay. Thank you,
Okay,
Sunny. Thank
please
you.
go. Thank you.
Yeah. Okay. So I'll start, and one of the announcements what Sunny already made is don't make any announcements. All right. Whatever questions and queries are, you can always send it on the mail, or we can, of course, we can discuss here at the end of the presentations because time being a constraint. I will run through that, and we can always revert back to you one to one through the CCMA webinars at gmail.com, and some of the questions are quite interesting, so it's good to have your feedback on that also. All right. So what I'm going to cover today, I will quickly run through the agenda. We'll quickly introduce you to the service life of a structure and introduction to the corrosion. By and large, most of you are aware of it, but just to evolve the subject, I'll be touching upon that. I'll introduce the dual phase migratory corrosion inhibitor systems. What are their applications, advantages? What are the proof concepts, and what are the test reports that has been gone into picture? And then if there are any question answers, and if we get more time on that, we will still discuss. So if you look at the holistic life cycle of a structure, uh, on the x-axis if you have the time, and the y-axis if you have the structural condition. Say in a span of 5 years my structure is good, and the condition is healthy. Over a period of next 5 years it falls down, and this is where I enter into my first cycle of the concrete repair. So my health condition of the structure comes down, and due to the repairs that I do, it's increased. Over the next span of 5 years it again deteriorates. Then I do my second cycle, and then my strength increases, and so on I do. But ideally what should happen is when we do our first cycle of concrete repair, my condition that has enhanced should continue over a period of time to just enhance the service life of the structure. So there has to be an added value that is required during the repair, and the best part would be if you can take the added value over here or over here during the construction period itself. That's the best part. Okay, so service life, if you see, is divided into three parts: the technical service life, the functional service life, and the economic service life. So I'll not go more into this, we all are aware. This is just, as I said, I'll be touching upon the technical service life and the functional service life. Most important, economic service life, of course, takes the important role at a later stage. But if you see the functional service life, it's divided into four phases. The first phase is the monitoring of the structure. The second phase is the preventive maintenance before the corrosion has initiated. The third phase is the repair and maintenance after the localized corrosion has been initiated. And the fourth phase of the structure is when there is a repair and replacement that is being done. So if you invest $1 in phase one only itself during the construction time and you are monitoring the construction, you will end up in equivalently spending $5 at that stage of the structure during the preventive maintenance when the corrosion has not initiated, which will be equivalent to $25 when the corrosion has just initiated in the structure, and which will zoom on to $125 when you actually go for the repair and replacement. So most of you are aware of this. It's the famous de-Sitters law of five: give me now or give me later, and the amount that it escalates to over a period of time. Now, the environmental conditions are, of course, not within our control. The chlorides, the sulfates, the carbon dioxides, leakages, there are certain things that we need to take care besides making our concrete durable, besides maintaining a good strength, besides maintaining all the technical parameters that we are monitoring during the construction of the concrete. But still the exposure conditions are beyond our control, and that's where nature plays its role, and we need to take care of that. Again, this is how the chloride induced corrosion happens, that it penetrates inside through a crack, and then there is expansion of the steel, development of a stress, and then the cracks are still further enhanced, and there is more chloride ingress that happens, and eventually the spalling and the deterioration of the concrete takes place. That's how the chloride induced corrosions take place. The carbonation induced corrosion, my last talk also I discussed in very detailed about how this process happens. A very simple process of carbon dioxide reacting with water and the calcium hydroxide to form calcium carbonate, and eventually reducing the pH of the concrete and initiating the corrosion of the reinforcement steel. So that's the carbonation process, how the concrete corrosion takes place. And if you see the volume of expansions of the metallic iron and the various oxidation stages over a period of time, you almost have 600% expansion of steel that happens when these corrosions set inside the embedded metal concrete. Now, there are various corrosion prevention techniques: electrochemical systems, anodic systems, cathodic systems, various chemical techniques like the inhibitors that I'll be touching upon today, actually changing the chemical composition of the electrolyte through which the inhibitor will be flowing, because for everything you require a medium through which the chemical exchanges take place. Of course, we have protective coatings, like there are polymer coatings, there are cementitious coatings, there are zinc rich epoxies. So in a nutshell, there are various provisions, prevention techniques that we generally adopt depending on the extent of corrosion, the area, the commercial aspect, and the exposure conditions to which the structure will be in the future. So just as a nutshell, that was how the things are. Now, even the EN 2061 specifies that for corrosion inhibitors, we should be using where you have chloride induced corrosion. For carbonation corrosion and for freeze and thaw effect and for aggressive chemical environment, there are various solutions. But even the EN code suggests that chloride induced corrosions can be very actively taken care by corrosion inhibitors. So let's dwell upon what these corrosion inhibitors are all about. So what I'm trying to introduce today is a dual phase corrosion inhibitor. So what are inhibitors? Primarily, these are the compounds, as I said, that when added to an electrolyte, which more becomes like a medium, its purpose is to decrease the corrosion rate of the metals or alloys after migrating through the porosity of the concrete. We all know that concrete is a porous material. However fine best of the concretes you make, whenever you're going to pour water, it's slightly going to get absorbed into the surface, and the molecule of this types of inhibitors are very, very minor to a very small dimension, even smaller than a micron, maybe thousand part of a micron. That's if we go into the nanotechnology part. So these corrosion inhibitors, what are the functions primarily that we look at? These products should be applicable both for chloride as well as carbonation induced corrosion. So they should be able to tackle corrosions that have already been initiated due to chloride attacks or due to the ingress of carbon dioxide, and parallelly they should be able to mitigate any further corrosion due to chlorides and carbonation. So both the processes are very important, that the product or the system or the technology that you're trying to apply should cater to. It should be effective in high humid environments. By and large, if you see, as a continent, India, at most of the places we are surrounded by a coastal zone. We have one of the largest coastal lines across the country, and it should be effective in these high humidity conditions. It should change the electrical properties of the steel as well as the concrete in terms of the Coulomb charges and the resistivity that will be passing through the reinforcement bars. It should have a long service life and effective on concrete even with cracks, and it should have a performance which should be proved by independent lab test along with the functionality, how it's functioning over a period of time. It's not only today, it's we need to, as we initiated discussed, that it has to enhance the service life, so its functionality over a period of time is also equally important. So these dual phase surface applied corrosion inhibitors, and what are the technologies? It is a revolutionary blend of high quality silanes. Now when I say silanes, you can automatically imagine what is there, what is the size of the molecule, and it also has an additional corrosion inhibitor. So a silane technology by itself reduces your water permeability, and if that silent technology is combined with a corrosion inhibitor in that, it's going to be like, a double bonanza for the concrete in terms of the protection as well as for protection against corrosion. It delays the onset of the corrosion and it reduces the active corrosion very significantly. So that means if the concrete and the embedded steel is already corroded, it is going to reduce the further corrosion process that is going to happen. As I said, effective both in chloride and carbonation induced corrosion, significantly reduces the water ingress, obviously because a silane based technology is there, and also prevents the chloride ion penetration, strengthens the passive layer on the steel reinforcement, and increases the electrical resistivity. So these are the important parameters in terms of the technology that we look at. So if you go, what are the requirements? It should be a clear liquid. Ideally, it should be applied to on hardened concrete, which when combines a power of 100% reactive penetrating corrosion inhibitor and a latent phase corrosion inhibitor. Now, a latent phase is very important because we all understand that eventually over a period of time, because of the exposure conditions, my concrete is going to crack, and when these cracks appear, these latent phase corrosion inhibitor part comes into picture, and it further penetrates into the concrete, and increases its barrier system. And this should all be able to eventually mitigate the electrochemical corrosion of the reinforcing steel either in new concrete or in existing concrete. So if you see the properties, as I said, the molecular technology combines the silanes and the latest corrosion inhibitors with a dual phase application. Then we have a single component ready to use, so there is no mixing that is involved. These are very simple applications. You just need to open the can and apply the material. It should be easily brush or spray applied or with a roller, simple to use, no change in concrete appearance, very user friendly, and finally it prevents the corrosion even if it has already started. So if you just look at what is the particle, what is the molecular size. If the coatings are more than 200 nanometers, then my silent technology is almost 1 nanometer. So you can say about thousandth of a micron. So that's how thin the technology is, and that's what allows it to penetrate into the open pore concrete structure. And that is the reason we should apply on the concrete, because it has to penetrate. The more it penetrates inside, the better protection our reinforcement bars and the overall service life of the structure is going to increase. So that's how the mechanism occurs, that it's finally penetrating into the reinforcement through the concrete and forming a passive layer reinforcement over there on the reinforcement bar. So the protection employs dual functionality. As I said, the silent base, it provides a similar benefit to a water repellent sealers, as we all know, and the corrosion inhibitors are carried into the concrete along with the silane. So they migrate with silane being the electrolyte into it. The inhibitors, they remain in the concrete until the water repellence diminishes over the time, or until the concrete cracks. Now when the concrete cracks, say after 2 years, then they again become mobile and they are carried deeper into the concrete, and they continue to protect the steel reinforcement because of the passive layer that is formed around the reinforcement also. So one, okay, yeah. So the dual functionality of these systems, they provide excellent corrosion protection not only on non-cracked but also on the cracked concrete, and the concrete which will be probably potentially cracked in the future. We assume that it should not crack, but then the structure will be exposed to certain conditions, and taking that practicality aspect into picture, that's how the system and the technology works. I'm sorry, I have few meetings going on, and the notifications are coming, so I apologize for that. All right, so that's how it is. So it's a small video that I will play over here. I don't know. Yeah. Okay. Yeah. Okay. I'm sorry. Yeah. Okay. So that was just a small animated video for just for everyone's benefit to understand how the system works and how the penetration occurs. So few of the am I audible, Sunny? Am I audible?
Yes, you are. Yes, you are.
Okay, okay. So quickly going through few of the advantages and what are the benefits of this. As I earlier said, it's a very nanotechnology system, and the silanes and the latent phase corrosion inhibitors, more important even for post-application cracks that may happen. The surface appearance remains unchanged if you want a firm finish concrete. It delays the onset of the corrosion, and effective both against chloride as well as carbonation induced corrosion. Of course, if there is a need for an aesthetic painting that needs to be done over and above, it can be done, because this is entirely migratory and it penetrates inside. So you all have an option of still providing decorative paint over that, and minimizes the maintenance and the operational downtown costs. So overall, if you sum it up, it extends the service life of your concrete structure. If I go to the first slide that we were discussing, that's what your repair has to do, or initially during the construction and monitoring phase, if you include certain technologies and systems during your construction, then your service life is automatically extended. So this is what the advantages are. Of course, now the applications are extensive. uh, Residential structures, the marine structures, you have silos, industrial structures exposed to coastal air, bridges, viaducts exposed to marine environments where the chloride induced corrosions are high. The application part is, as you can imagine, it's quite simple. Concrete has to be properly cured, and it should be having at least 80% of its design strength. It should be applied on a dry surface, because we want the material, the silane, to penetrate inside, and it should not be diluted with water. So all the loose and spoiled concrete, in case of an existing structure, that needs to be taken care of, repaired properly. And if there are any cracks, then we suggest you can pond it, or you can fill the crack even with this liquid. So it's a added benefit. In fact, the crack becomes as an added benefit, that the material can still go inside more than what it can through the surface. So that's in fact a favorable condition for the structure, that the material will penetrate still further. The surface concrete profiles should generally be as per the ICRI guidelines in the CSP 3 to CSP 5 profile. And for that, of course, all the requisite cleaning techniques that are required can be adopted. Of course, all the equipment and the protective gears, like the sprays or brushes or rollers on a larger scales, can be used too. The application method is very simple. Just open the product, and it has no dilution that needs to be done during applications. The surrounding area should be protected. You apply that on the dry concrete, and then just leave it for about 15 to 20 minutes to penetrate, and then just apply the additional coats. So that's how the application remains. It's quite user friendly. Of course, on a larger areas, you can use non-atomizing sprays, or heavy equipments to spray the entire surface. And of course, we have done a lot of proof testing of the product in Spain, in Germany, in US, and a few of these tests specific in related to the electrical resistivity. I'll not go more into that as per ASTM G109, because I guess, Sunny, we are slightly short on time. So I'll quickly move on. But an interesting part that you can all appreciate, that for a non-corroded, one minute, for a non-corroded specimen, when the dual phase corrosion inhibitor was applied with so many months of ponding of sodium chloride solution, what is my electrical conductance in terms of coulombs, you can see here. And if it is uncoated, what is my coulombs that are passing. If you look at pre-corroded specimens which were allowed to corrode for a period of 3 months, and after 3 months the material is applied, the dual phase corrosion inhibitors, what is the current passing through them, the amino functional silanes and the uncoated ones. Now these were for pre-corroded, but if you see for the cracked and the non-cracked specimens, so the coulombs passing specimens, they were cracked before the coating, and the material was applied, you can see here. And the specimens were cracked after the coating, you can see the line here. And the specimens where nothing was applied, you can see the uh, values over there in terms of the coulomb charges. So different comparisons are there. We there was a lot of extensive study also that goes into this technology in how the coulombs and how the resistivity of the product and the technology can enhance, which maybe I can cover it up in one of the next modules. And you can see just few of the areas, of course, where these systems have been uh, successfully applied, and they have been checked even after 2 years of the treatment, where the technology has functioned. Few of the ports and the jetties and factories in Gion in Spain. So overall, if you summarize, it's a very cost-effective solution in terms of the service life of a structure, and it quantifies the savings in the maintenance cost over a period of time, and that's what we are looking at. In terms of technological advantages, the efficiency against chlorides are very high for the dual phase surface applied corrosion inhibitors. Efficiency in carbonated concretes are very high. The efficiency you already saw in pre-cracked concretes are very high in comparison to the different technologies that are there. In cracking after the treatment, it's much better than any of the systems or the technologies available. The long term efficiency over a period of time, the ease and handling, as you could see, it's a very simple open the container, apply material, very safe material, non-hazardous, and very easy to store. So that's how the things move in terms of a comparative chart that we could find out. So that's all I had from my side as a short introductory note on this technology. And we as a learned Indian audiences and Indian construction people, we need to adopt these techniques and of course enhance the service life of all our structures. So thank you very much. So that was all from my side, Sunny. Hope I did not extend more.
No, not. I think we are in good time. So thank you
Yeah.
very much,
So thank
Deep.
you. Thanks.
I
Thank
would
you.
also once again request our viewers to put up any questions into the chat box, and we will definitely take it up at the end of the session. So right now, I think we can continue with our session for today. And if I can request, Nikhil to start up with the presentation. Yep, the screen has come on. You can just go to
Yeah.
presentation mode.
Just hold on this. Is my voice is audible to everyone?
Yes, the voice is audible. Yes.
Perfect. Um, Hello everyone. Thanks Sunny for this wonderful opportunity to interact with all of you. So myself,
Perfect. That looks
Nikhil.
good. So you can go ahead. Nikhil, if you want, you can put your camera on if the need be, or that's not a problem either way.
No,
So
no, that's pretty fine.
okay, thank you. All the best.
Thank you. Uh, yeah. So yeah. So thank you everyone. It's a good opportunity to interact with all of you. Myself, Nikhil Bhatia. So I have a 10 years of experience in construction chemicals and widely, working with BSF and one more organization. Uh, the topic, what we are going to discuss today is polyurea, polyurethane resins. Uh, what are the kind of materials, what are the challenges, what are the limitations of the technologies. So we'll just quickly look to cover, though this is a vast subject and it requires a you know uh, it requires a significant amount of time to you know uh, each and every project is different, and then we have a different lookout for each kind of requirement. But in a limited hours I will cover some important aspects of the technology. So the agenda will be a brief discussion about the definitions, then we will discuss about various technologies available. Then I would like to stress upon the importance of the surface preparations, because this is somewhere what I feel is that the liquid technologies, with our huge experience of more than 70 years in this, so the liquid technologies is more like 50% of the surface preparation properly if we are doing, then we have a huge rate of success. Yeah. And then what are the limitations of the technologies. So all of you, many of you must have heard about polyurea. So basically, this is more like a isocyanate and amines. When they are in touch in a chain reaction, they form polyurea. While the polyurethane is more like a isocyanate and polyur or hydroxyl terminated compounds. And while the one of the upcoming technology, or very famous technology, is hybrid polyureas, which is cross linking of isocyanate and both amines and hydroxyl terminated compounds. So based on the requirements of the building, so let me tell you, a pure polyurea globally has a very good acceptance in underground structures like ETP tank, STP tank, because of a high chemical resistance. While polyurethanes are more flexible in nature, as soon as amines comes into the picture, the setting time reduces of the system, and then the system mechanical properties increases. So and then the system becomes quite fast setting and in being very useful for multiple applications. So now we have the technologies like modified PU, modified by the bitumen, modified by the acrylics. Yeah. The another technology is pure polyurethane, does not have any modification. Yeah. And then we have a hybrid polyurea in our in the available in the market, the pure polyurea, hybrid polyurethane. And then we have both the products, all the kinds of products are available in hand applied and the spray applied version. So this is the basic portfolio which India is offering. Yeah. And if you see, the conventional waterproofing, liquid waterproofing system generally is having a mother slab, and then you have a waterproofing coating directly above a mother slab. Yeah. So this is something which we are doing, and many of us are doing in multiple projects. Now, with our 70 years of experience, while hit and trial method, how we can become more successful, what our experience is that the primer plays a very important role, and we have a 4-layer kind of system compared to a single layer system. So the first layer is, we'll talk about, just I'll put a pointer. So first layer is the primer. So it should be a deep penetrative primer which should saturate the top layer of the concrete very well. And then we should have a waterproofing membrane, and wherever the waterproofing membrane is exposed to sun, all the areas shall be protected by a UV top coat. Now, let me tell you what is the benefit of this system. So all the liquid waterproofing has a single limitation of development of a pinholes, right? Which I'm going to cover in upcoming slides. But suppose I have a pinhole in this particular area, but I have in this particular area, but I have a good primer below it. So what will happen that even if water enters till here, because the bottom layer of the concrete is saturated very well with the primer, so the potential leakage may not come. So this is one of the benefit of a primer. I will discuss further benefits once we approach, but it has the entire technology, or the built up has made us very successful in the market, and the technology has given very good results. So while the systems can be done directly above the mother slab, but the primer is much needed. So the system looks like this. We will have a surface preparation, then the substrate can be concrete, metal, or anything. Then you have a primer, um, and then the waterproofing membrane will come. So waterproofing membrane, the primer, epoxy primer is cannot bridge any cracks. Yeah, it will just increase the reduces the porosity of the concrete or the top layer. But when the waterproofing is coming, it will take care of the crack coming into the concrete. Yeah. And then the top coats, we all know that for the UV protection systems, right? So now the 3 kinds of technologies I have discussed in the previous slide, I just forgot to elaborate. While the liquid applied systems are meant for a mass market, where you don't need a very heavy equipments, or you just need a airless spray machine, or you can use a brush roller to do the application. And it is widely accepted in India and globally. And if anyone of us is wants to become an entrepreneur, so it does not need a very big investment. While the fast setting systems like polyurethane or polyurea requires a special two component machine and a very skilled labor to do the application. So this is a one of the limitation that uh, that India has to develop itself for the these kinds of fast setting technologies, which can also give a equivalent very good results and a long high performance life in the waterproofing systems. So why do must have experience that we do waterproofing, and after 2 years or 3 years there is problem coming. And in the last previous slide I discussed why we need a primer, why surface preparation here. So there is a correlation. What exactly the data says that 50% of the waterproofing fails. Why? Because the surface is not properly prepared. Yeah. And then incorrect material selection, which has a 40% of the role. And then third is because of the moisture in the substrate, and the waterproofing whatever we are doing has a adhesion problems. So we have to get rid of all the three issues: the right product, properly prepared surface, and a and a and a proper application combines a successful waterproofing application. So let me tell you what are the problems. Yeah. So if you see in a polyurethane systems or a liquid, any liquid systems has three basic issues. One is poor adhesion. Second is pinholes, blisterings, and blisters in the membrane. And third is pinholes. Yeah. So why is it coming? So just going to the more into the chemistry part, what I would like to explain you that poor adhesion is generally because of an inadequate surface preparation. The concrete may have, the top layer of the concrete may have some sort of contaminants, which later on create the problem of the adhesion problems. And then we have a weather condition, so maybe too much moisture, or that the surface is still getting a dew point, reaching the dew point, and because of the weather conditions these problems can come. uh, the last two which I'm trying to highlight is more related to the application. So exceed the overcoat of the primer. So I apply a primer today, and after 3 days I start my waterproofing application. So the primer gets contaminated. That's where the problems can come. And then you do the coating. So you do a hand applied polyurethane system or a hand applied polyurea first coat, and then after 3 days, after a specified time, you are doing the second coat. So that is also a problem. So the last two is more like a application problem, and the first three is something which by a proper surface preparation we can control. Now the blistering is something that is also seen in the waterproofing systems, and generally because of the chemicals in the subsurface can react with the waterproofing membrane which is done over it, and that can also lead to the blisters. uh, Also, the concrete is breathing, or some sort of moisture available in the concrete, so that moisture potentially wants to go up or rise, and that also creates the blistering problem. While the pinhole is more like a concrete which we are over which we are doing the waterproofing membrane is regularly breathing. And while we do a liquid membrane or a fast setting systems, while concrete is breathing, uh, the membrane, the air pressure exists on the weak liquid membranes, and then that forms a pinholes or this. Also, pinholes are seen in the membranes because of a inadequate, when you apply the waterproofing membrane at a too much of the thickness. So that is another reason. So would like to explain you further why surface preparation is required. So generally, the concrete, if you see while you are doing the vibration, there is a high tendency that the bleeding water comes to the top 6 mm of the concrete. So if we are doing any bonded system over a membrane, what can happen actually that because we are doing a bonded system, the top layer of the substrate is weak. Yeah. So that can potentially debond, and waterproofing can potentially crack because of this. The second important area is use of vapor barriers or a curing compounds, which needs to be properly removed. Sometimes vibrated, when we are doing the vibrations, the slurry goes out of the uh, uh, out of the shuttering, and when you are doing the waterproofing, that area has a lot of uh, a weak area of the concrete, and that is also the reason. Apart from that, insufficient curing also leads to the problem. Micro cracks. So many times we say that you go for a mechanical grinding. So micro cracks are there, which is not very much visible to you at the time of the application of the membrane. That potential cracks can increase its size or later on give us the trouble. So treating each and every aspects properly is something we always say that it is very important for a surface preparation. And the sharp protrusions, so say you have a unattended sharp object on the concrete over which you are doing a 1 mm, 2 mm or 3 mm membrane, which is very less. When you have a vehicular traffic or a fire tender movement on the podium, that can potentially give us a trouble. So the best, there are the guidelines, which is ICRI guidelines, which I'm presenting from CSP1 to CSP10. So these are the level of finishes, and they suggest that for what kind of application, what level of surface preparation is required. So for a thin or a low build thickness, they say that we have to go to CSP2 or CSP3, and a high build thickness, so CSP5. So this is the level of surface preparation we need to achieve. Now, if you see the various methods which are available, like mechanical grinding, short blasting, abrasive blasting. So to achieve a CSP3, you can easily achieve with a mechanical grinding, which is one of the famous surface preparation methods for the roofing applications, and that is that you can easily achieve good finish using this technology. While you for the roofing applications, you have slight more flexibility from 2 to 5, and for the traffical cable decks or a car parking system, we can actually require a CSP5 and CSP. So the need of the surface preparation changes by the need of the by the requirement. But for the thin films, definitely a good surface preparation is must. Now, talking about the primers. Now, the concrete where your waterproofing has to come. Yeah. So the top layer of the concrete, the primer act as a densification of the thing, which I have already discussed. The top layer becomes densified using a primer. It also act as a bond bridge between the concrete and the membrane. While the primer penetrates inside the concrete and membrane, waterproofing membranes has a very good bond with the primer. The system works very well together. So polyurethane as a nature has a limited resistance to the alkaline, and many times what happens that concrete being a alkaline nature, the top surface has lot of alkaline properties. So if we don't have a separation primer, so alkalinity of the concrete can react with the waterproofing systems and has a problem. So that's where it is chemically required to go for a good priming system. Then, depending on the project demands, primer can serve some other benefits like humidity barrier, especially in the retaining wall applications. And primer uh, in the concrete significantly remove the bubbles, because it is acting as a sealer. So if you are doing a proper mechanical grinding or a proper surface preparation tools plus primer, then the three problems of a waterproofing systems can be resolved. Now, uh, product selection. So product selection is something that is very important. We have to understand the built-ups, understand the drawings, what level of the roofing structure is there, what is the profile of the roof, what is the slope. Like in India, we are going for a zero slope system. The RCC's mother slab is totally flat. Then the kind of substrate we have to analyze. So sometimes we have so many pedestals, so a waterproofing has to be bonded to steel, concrete, metal. So we have to take care of that. Then the UV stability of the system. So many times we have to expose the membrane. Water vapor transmission. Your waterproofing should always be breathable. So these are the basic requirements which we have, which when any waterproofing prospect, when we are approaching, we should have a proper questionnaire ready to analyze the whole situation and place a right product. Yeah. Now, if we talk about the chemistry, now if you see acrylic waterproofing, which is more like a linear chemistry, it is just like a burger. No layer of the burger is interlinked to each other. Moisture cured polyurethanes are more like a branched chemistry. So basically, it's like a seek where all the I'm just showing you the photos of some food items. At this time, we cannot go out also to eat, but I apologize for it. But the idea is to explain you the concept. So no layer of the membrane is connected to each other, but they have a branch structure. While we talk about a polyurea two component chemistry, it is more like a cross-linked structure. So it is something like a wooden plank where I have first plank, I have uh, a polyurethane adhesive, and then I have a second layer of wood, and then for a more safety, I just put some nails inside it. Now this bond cannot break, and when we do the testing of these chemistries, uh, you know, in a accelerated weathering conditions, we see two component chemistries performing better than the single component chemistry. So let me show you some of the examples. So we also see, because of the chemistry itself, we see the performance for a mechanical properties of two component is higher than the single component, and single component can give you better mechanical properties than acrylic systems. So I'm giving you one of the examples to compare a single component chemistry with a two component chemistry. When many of the single component chemistries which are very rich in acrylics, or has a very good example that you submerge the waterproofing membrane for a very long duration, maybe for a year, you see there is a color change. Something like this, the picture in your left. So there are some testing which ETA is doing. So what ETA says that, okay, you have a initial tensile strength of the waterproofing is 8 MPa, but once you are exposing it for 200 days and 80 degrees C, your tensile goes to 4 MPa. So this is something I've not taken or not specific for any report, but just for your explanation, I put these data. So similarly, the elongation from 500% becomes 200%. So there is a significant loss of the properties when you are having an accelerated weathering condition. Similarly, when you are putting the systems in UV, if your system is not aliphatic in nature or a UV stable in nature, then you see a significant fall in the elongations and the significant fall in the tensile properties. So when we tested one of our two component chemistry, we saw that initial properties, like in a controlled condition, it was showing a 707 MPa tensile, 300% elongation. In a heat age condition, if you can compare, the test method is very similar. But what you see here is that in 200 days, 80 degrees C. So you see that there is no reduction in the heat aging properties of the material. When you are exposing to UV, the tensile goes down and elongation also goes down, but the impact is not more than 10 to 15%. When you are exposing to the water, we are getting even a higher performance properties, which no one can justify why we are getting. But the idea is that uh, you are able to maintain the properties even in a long run, which means that the waterproofing is going to give you a good life when exposed to the real situations of the roof, where we have a flat roof and a long-term water stagnation in the presence of heat. So that's something that Toyota is doing the testing, and these are if you see BBA or Toyota, these are very expensive testing that uh, has to be done in the waterproofing system, and gives a very good justification how the waterproofing exactly is. Now, if you see the single component chemistry, uh, it is a good product, but one parameter that we need to understand is the moisture cured chemistry. So many of us aware of the limitations of the moisture cured chemistry, but those who don't know, I would like to share the same. If you see a curing of a membrane, now it needs moisture from the air. So while the curing process, while you lay the membrane, it takes moisture from the air and cure itself, right? Now the limitation is that if your relative humidity, the humidity in the air is more than 85%, less than 85%, from 50 to 80, it gives a fantastic film. Yeah. So if you see most of the Indian condition, it is not a problem. But a place like, but we have to think in such a way that a place like Mumbai or a seashore area near to Goa, where, the relative humidity exceeds 85%, and you try to go for a single component chemistry, the problem is that it will absorb so much moisture that, the film formation will be more porous in nature. Now, it also depends on the formulation of the system, where what kind of equipments manufacturers are using to develop their single component chemistry. But in general, these are the limitations. So too much moisture is a problem. Too less moisture is also a problem. So maybe you are doing somewhere in a very dry condition, so curing will not happen. So maybe 24 hours or 48 hours, the curing will not take place. So this is one of the limitations for a single component chemistry, while a two component instant setting or fast setting systems are sets in 20 seconds. So now what we do, that a water molecule in in one of the a product range, we have hydroxyl ion already there in the chemistry. So the limited amount of moisture is already there, which enables a fast curing of the system. And the system, all the systems available in this range in the Indian markets, sets within 60 seconds. So one of the limitation, because it is a moisture cured system, that you cannot build up a very high thickness. Yeah. So with our global experience, we have seen that some of the manufacturers are very good, and they can allow you a single component chemistry product to be applied at 1 mm or 1.5 mm systems. So but these single component chemistries are very, very expensive, and these are the actual real products that should be used actually, and very few people are having this kind of technologies. But this is ideal for a global condition where a place like Europe, where the cost of the application is more than the cost of the material. But in India, we can still go for a lower thickness like zero point 0.6 to 1 mm and still do the waterproofing applications. So the time you try to do the waterproofing at a very high thickness, then you may have the problems of bubbling the pinholes. The second problem is that if you do it at a very high thickness, though, so the top skin can be cured, but the bottom skin will not will remain uncured, because it will not get moisture. So these are the two limitations that uh, we feel. So we did a pull-out test and see the structure of a single component, and then we cut the two component product and a one component product, and we when applied at a higher thickness, we see the film formation is also better in a two component. So it totally depends on how we apply. If so, the product is good, and if applied in a proper relative humidity, at the same time applied taking care of proper priming, proper surface preparation. So single component, if you see any of the ETA certificates, give a very good life performance life as well. But if we see that we have more flexibility in a self curing systems, hand applied and a spray applied two component waterproofing systems, which forms the film in a single go. So you can develop a film of 1 mm, 2 mm, 3 mm in single layer. At the same time, the film formation is better. Now talking about another thing is the application of the vertical. So uh, what the thing is that if you go for a spray applied fast setting system in a retaining wall, maybe sometimes a over specification. Why? Because these system will not sag. What is the problem in a vertical application, especially in the retaining wall generally, that you cannot apply a single component or a liquid membrane to a very high thickness. more than 3 mm, 0.3 mm or 0.6 4 mm, it is a challenge. Now applying, if we go for a two component instant setting, fast setting products, what will happen that many times your water table is not very high, then obviously we are over specifying our systems. So the idea is that if you go for a single component chemistry, then to achieve a 1.5 mm thickness, you may have to do 4 to 5 coats, while two components sometimes is expensive. But uh, if we go for a multiple coat system, what can go wrong is the contamination of the retaining first layer, and then as you know, in the retaining walls or in the basement, lot of dust accumulates. So you do the first layer, there is a high chances that the waterproofing membrane will get contaminated, and then you have to do the second layer. So the activity is very challenging. That's where two component is good, but at the same time we have to see that can we go for some preformed membranes which can take care of the cost part also and performance also. Or when we have a high water tables, probably we can go for a spray applied instant setting systems, which is more useful. But if we have to go for a price limitation and we want to go for a seamless system, then uh, single component can be done with a proper care and at a lower thickness. So the market that in a two component also we have certain thixotropic products, but when we get into those kinds of formulation, the cost increases significantly high. Yeah, perfect. More than the two component actually. So just I'm sharing you the brief about the economies and the limitations of the system. While we talk about two component instant static waterproofing, you can actually apply 10 of the thickness in a single multiple passes, but a single layer. So no waiting time between the membranes. Excellent addition, fast setting. So within 2-3 minutes you can actually start working on the system. Uh, Vapor permeable, no ballooning in the system, and then fully bonded. The membrane is like this. So I will just show you a brief video to have a feel of the system. So it's a very fast setting system. Material is sprayed on and immediately it sets. So excellent product when we are talking about vertical applications. Excellent product when we are talking about refurbishments, or when we have to do the waterproofing in slopes. So it is one of the product which we close our eyes and suggest in the refurbishment, because in a refurbishment roof slope is already there. So going for a liquid membranes always have a problem of a flowability towards the downward side. Now, if you see the bond with the concrete, if you properly apply the primer, sand broadcasting, and the membrane, then you get a very good peel addition to the concrete or a pull-out test from the concrete. Uh, Material can take any shape, any profile, and material can bond to any substrate. Yeah, it's a spray applied. And then water vapor transmission. So if there is any moisture entrapped in the concrete, then what exactly that the it is slightly breathable, and that certain amount of moisture can go out of the system without having any ballooning problems. uh, it is a root resistant, so has passed various international root resistance testing. Also, the product is having a high abrasion system, and this is the compliance photo, not for stating, but I always say in all my presentation that it is taken from a site after we go for a check. But this is how the India works. But it also tells that the material is very tough. So combined to all, it is one of the good solutions. And so idea is to balance the economies, where what fits well is the future, that somewhere we cannot afford for a very high end system. So if you have any questions, we can discuss.
Great, Nikhil. Thank you very much. That was quite an engrossing topic, and of course, roof waterproofing is, I think, something that a lot of people would be looking forward to now during the monsoon season as well. So, if we can have actually both you and Deep on the screen, then we can get into the question answer session. Deep, do you have him on board? Hi, Nikhil. Good evening. I can't see him here. Just a moment. Oh, yes, Deep is here. I think. Just a minute. Yeah, Deep. Can you hear us?
Hello. Yeah.
Deep.
Yeah. Yeah, Sunny. Yeah. Yeah.
Yeah.
Yeah.
Great. So I think there are few questions that came in during the course of the presentation.
Yeah.
So the first one would be. Um, the first one is, do manufacturers ensure guarantee of rate of corrosion for specific years by using MCI? So I'm not sure whether that's like a contractual thing
No. No. Correct.
or a
I
material
yeah.
performance thing.
Correct. Correct. Correct.
Do you want to take that, or should we go on to the next one?
No, actually, it's more contractual part. So I will not be able to
Okay, okay, great.
conclude on that.
The next one is from Mr. Satish Vachani. It says concrete cover deficiency can be taken care of by applying these chemicals. So if yes, are there any tests conducted to verify this claim?
No, can you repeat it?
The concrete cover deficiencies can be taken care by applying this chemical. So I think he means the
Concrete
corrosion
cover
inhibitor.
deficiencies can be covered by applying these. Yeah, okay, all
Yeah.
right.
And if yes, then are any tests conducted to verify this claim?
Of which claim means I'm not very clear. The claim of
That the
the
concrete
concrete
cover
cover.
deficiency, yeah,
Yeah,
concrete
so
cover deficiency
we
taken
can
off
of course with a rebar locator we can always find out, Yeah, of course we can do that. There are tests, there are entity tests which we can be implied at the site,
it.
and
Okay,
yeah, we can ascertain that. Not a problem.
okay. So things like I think rebar, then corrosion
Correct,
potential,
correct.
those kind of things. I think you can do an in situ test as well.
Yeah.
Great. Then there was one question from Apurba Malik. It says EIL long-term test has 5 parameters. Is it required that the corrosion inhibitor should pass all tests?
EIL for corrosion inhibitors, I'll need to read what are their
Yeah,
specifications because these are again organizational specific
correct.
requirements. So
Because I further asked them.
yeah,
I further asked them that could you elaborate on the tests referred to? So I think
correct.
they gave us a specification number.
Or maybe the specification clause which he is referring to. If
Yeah,
we understand that, because testing is otherwise becomes a huge
correct,
canvas to specifically answer to his required parameters.
correct. I think the specification number, if you want to note down, is 6-68-0017.
6-68-0017. Okay, I'll
Yeah.
refer it and revert back. No
And
problem.
Apurva, if you can just drop us an email, and we'll see if we can get the
Yeah.
answer to you. Then the next one is holiday testing mandatory for polyurea coating? This is from Mr. Ravindra Babu. Polyurea coating knowing fast cure system even on penetrating primer on concrete results in pinholes to ensure quality.
Can you just
So
repeat?
that means, is there normally any clause put in for holiday testing or to test whether there are pinholes, or uh, is normally something like that put into
There is
specifications?
there is no clause as such that it is a intrinsic uh, property of the substrate that can lead to the pinholes in the membrane, and it
Yeah,
can come in any membrane. So probably if we do a proper surface preparation and a proper priming, so I see many specifications where it is defined that the consumption of a primer is X to Y. Now many times when we start doing a project and we see that the primer consumption goes to 600, 0.6 and 0.6 gram, 0.8 grams. So should we follow the spec which is saying 0.15, or should we follow what is, so the concrete shall be properly saturated, and then if you do the membrane system, we will have a reduction. But it is something that can come anywhere. So properly prepare, properly prime, you will have lot, you will not much problem.
Yeah. And I think there has to be, I think, one something that says that that's, I think, part of the standard QA system, that people have to keep an eye out for this kind of defect and maybe just fix it on the go. I think that's the best that can be done. I don't.
So, as a construction engineer, you should say that properly saturation of the substrate. Because I myself have seen multiple primers. So I apply first coat, within 5 to 10 minutes, we see that okay, the entire primer has been soaked by the concrete.
Correct.
So
Correct.
if we have a limitations of doing a primer, then obviously, we are writing the specification, so the applicator will also go for a lesser thickness or a lesser consumption, and then we have more problems.
The next question, I think, is again for you, Nikhil. What is the process to treat surfaces previously applied with a bituminous coating? This is by Suadeep Chakraborty.
Yeah. So, bituminous. Okay. Now we have to be very consultative and very selective how we have to go ahead with the waterproofing of a refurbishment of a APP membranes or a SBS membrane, which potentially has lived its life and now leaking. Now the first step is that you have to see that how well the membranes are bonded to the substrate. Now many times what you see that the membrane is debonded in multiple areas, and we cannot do any bonded system over it. So bond to the existing substrate should be checked. If it is not very good, it is always advisable to remove the entire system, do the mechanical grinding. Now, once you do the mechanical grinding, you have two challenges. One is that lot of uh, bitumen which is there in the substrate can stick to the bottom of the blade. The second thing is, while you are doing the mechanical grinding, you may see that the primer which is used in the bitumen has penetrated so deep inside the substrate that potentially, if you go for a any waterproofing polyurethane system, might not have a very good compatibility.
Okay.
Then there is a role of a good primer. Now there is a primer which is available, which can act as a compatibility primer between the old bitumen and a polyurethane system. So it is slightly expensive than the normal epoxy primer, but should be used. So whenever we have these kinds of cases and client asks for the refurbishment, irrespective of anything, we specify the bituminous, the right primer for the situation, plus proper surface preparation, and then we have done lot of lakhs of square meter globally with uh, this primer and did the refurbishment.
It's a good suggestion. And the next one is again quite an interesting thing with regard to detailing. This is from Mr. Satish Vachani again. Is that polyurea spray application, is it suggested over or under the insulation material?
Okay, this is a very good question.
Detailing, based to detailing.
you know so now, coming to the National Building Code, which says that the we have a draft copy. I'm not seen, but even I can tell you right away, there is one more code which is saying that the waterproofing should be above the insulation. Now what is the problem that uh, can I go to the uh, I like to draw, but let me try to explain it here itself. That globally, what is the system is that we have a mother slab. Mother slab is slightly in a slope formation, right? And then we have a polyurethane system, we have a XPS board, and then we have a screed. System works perfectly well. But in India, we are having a flat slabs. Yeah. So waterproofing, while you do a waterproofing on the mother slab, then we have a XPS or PIR or PU, any insulation boards. What will happen while your screed cracks? So it becomes a pond between the top screed and the bottom layer of the membrane. So if you have any pinholes, you may have some sort of problems. So that's where again the importance of a surface preparation and the build-ups that we are going to say. So above the top of the any XPS board, we cannot do a bonded system. Now, if we go for a puff insulation, which is a spray applied seamless system, we have seen both the cases, the success and the failures. Now, if we there is no problem as such, what the National Building Code is saying, that the waterproofing should be above the puff insulation, right? So any moisture which is going inside the puff will, will lead to the loss of the insulation properties. So in technically speaking, we should have a product at the top. But practically what is happening in India, the system as a whole is perfect. The problem what we are getting is the mixing ratios. Agar wahan par kuch there is a problem, then there is a problem coming. Second is when a applicator is applying the second layer of the puff insulation at a lower thickness, then the first layer and second layer can debond and the waterproofing can debond and the entire system can have some trouble. So going to the chemistry of a puff insulation has a 90% of the content. So we should have a waterproofing on the mother slab, then a puff insulation, and as following a global specification, we can have a good high puncture resistant acrylic system on the top of the puff, which is the ideal solution for this kind of situations. Apart from that, the third kind of problem I forgot to tell you is the reinforcement that I have seen in multiple sites. The way, you do the puff insulation, you do the waterproofing on the top, and then contractor comes after 30 days to do the waterproofing while many people are accessing. That is also has given some sort of trouble. Then repairing it is a slightly tedious task. So some limitations, but either way we can go ahead.
So I think based on the system, then maybe a 2-layer waterproofing, like bottom and top, might be necessary based on detail.
India is one market which has grown within 10 years from a brickbat Koba to a 2-component, from a 300 square meter system to a 2,000 rupees square. So they will adopt.
Yeah, it is like Bullock carts and Porsches coexisting on a road. So it's somewhere the kind of same thing that happens in waterproofing as well.
It needs only failure.
Yeah. Correct. Good detailing. This question is for Deep. It says, can MCIs be directly applicable to reinforcement bars? This is from Jayanti Avlani.
Jayanti bhai, કેમ છો?
I don't think they can speak.
All right, no problem. So, Jayanti bhai, no, we cannot apply MCIs directly on the reinforcement. I mean, if you need a protection coating on the reinforcement, of course, I earlier mentioned you have zinc-rich primers, you have cementitious coatings, you have epoxy, fusion bonded epoxy. So those are the systems basically because they have a micron thickness. They have a molecular layer thickness. As I explained to you, the MCIs are very, very thin. The molecular size is very thin, and they will not be able to sustain directly on a surface. It has to be penetrating inside the concrete. Yeah.
That's a good one. And the next one is a very interesting part. Is something we always interesting question in waterproofing. For honeycombs in concrete which are not visible before waterproofing, what should be done after leakages appear?
Okay. Before waterproofing, if you are doing a proper surface preparation, I think everything will come to first two fundamentals of waterproofing. Prepare your, even if we go for any test, we prepare ourselves well. So before waterproofing, it needs that kind of preparation. So many times what happens that your top surface is fantastic. It looks fine, but while we do the mechanical grinding, we see cracks, we see all the hidden things what contractor does. So, if there is honeycombing structure, you see that your concrete will absorb a lot of primer. So it will solve. Follow the fundamentals, it will not. But if there is a problem, let us have a injection from the bottom, can be something that can be done.
So well begun is half done, Nikhil. Yeah.
Always. I think there are these. This is again from Mr. Ranjit. I think these two are connected questions because it's come one after the other. It says, what is a TTCI, traversing type corrosion inhibitor, and the spec says inhibitor shall have corrosion inhibitive monomolecular film in vapor phase.
I'll have to look into that.
We'll have any ideas, Deep?
No, monomolecular liquid, I mean, of course, they are also penetrating, but then specific to this technology, I'll have to also dwell onto it, Sunny.
Okay. Another very interesting question again from Jayanti Bhai is, if concrete is impermeable, like using crystalline admixtures, will MCI work?
Yeah, it will. Because of the molecular technology, it will still penetrate inside. That's the fun part of it.
Okay, so that's interesting. And the last, I think, the last couple of things, last few questions that we have. Um, I think this is covered. Satish Bhai had another question that if the concrete cover is less than adequate, I think we have taken this before. Then can the material cover up the
Yeah, yeah,
deficiencies? So that has been
yeah.
covered. And I think yeah, I think that's more or less. I think more or less you've covered. There is one quick question about which system would be suitable for below raft waterproofing or deep basements. I think that we covered in an earlier I think in an earlier session altogether in great detail. So even for most of our viewers here today, you're please feel free to take a look at our YouTube channel. Like even if you just type in CCMA, I think you should be able to access our YouTube channel, in which all the previous you can view all the previous web talk sessions as well. And the last one I think that we can take in is, do we have water based bitumen spray applied single component coating, and can we do PUF over such a coating? Will it have good bond strength?
Water based.
Water based bitumen spray applied single component coating, and
Hmm.
can we do PUF over such a coating? Will it have good bond strength?
Hmm. So this bond strength, I think I feel some other chemical compatibility issues. I think we have done some test and then I cannot recall right now, but I think may not be a right time to answer, but we have to do some testing on the chemical compatibility. I seriously doubt on that.
Okay, so I
But
think, oh, yes,
bitumen kind of products are available in the market, water based.
yeah. I think it's always best to do an on-site test. I think most of the time that gives you quite a good indication, like what can be done, or
Actually, problem is that uh, with the polyurethane to polyurethane compatibility, no one has doubt about it. So let me tell you one of the example. When we try to put any solvent in any insulation, the insulation goes for a toss. Now, also this is somewhere I heard from a senior, but I don't have any data. Otherwise, I would have told you. But there is some problem in a long term where the bitumen has a problem with the insulation. So we have to check. I will come back to you.
perfect. So thank you very much. Thank you very much, Nikhil. Thank you very much, Deep. I think it was a quite a good, interesting session with two little bit different technologies. Like one getting more towards concrete protection with corrosion inhibitors, and the other one with roof waterproofing. Something that's very relevant for this season now. So hopefully, people should get their roofs done as fast as possible, prevent the water coming in. And I think with that, from me, Sunny Surlakar, your host for the evening, I would say thank you very much to everybody, and we can conclude today's session. So, of course, look out for our next announcement. We would be having another session in the middle of August. I think just before Independence Day. So we'll see each other soon. Okay, thank you.
Thank
Have a
you.
nice evening,
Thanks.
everyone.
Thanks, Sunny. Thanks.